All right, we've played a little bit with radical expression. Let's play a little bit more and look at simplifying some radical expressions. So we'll look specifically at doing some multiplying, and we'll look at dividing. Okay, when you are multiplying radical expressions, the only way you can multiply the radicands underneath is as long as the index for both of them is the same. In this first example, I can't multiply those two underneath. It's not equal to, because this has an index of 2 and this has an index of 3. Can't do it. So if I was wanting to do it, I guess I could rewrite them as fractional exponents times 4 to the 3/4, oh no, 1/3. And I guess I could maybe write them as, try and get a common denominator up here, so 3/6 times 4 to the 2/6. And then sort of do that factor out thing that we did in the last section, where I'd have 5 times 4. This would be a 3, this would be a 2, and the 1/6 I would bring outside there. Again, if I go backwards, the 1/6 multiplying by here, it would give me what I had up top there. Continuing to simplify, 5 cubed is 125. 4 squared is 16, all to the 1/6. So I'd figure out whatever 128 times 16 is. That's a big number, 2096 or something. I'm not exactly sure what the number would be. But I'd multiply those two numbers, and whatever I'd get there, it would be to the 1/6. And I guess I could rewrite it and have a 6 out here and have the number out there. That's sort of a long way around things. But you know you're going to have to do something like that if the indexes are not the same. Now, other kind of simplifying that I can do is if I'm looking for the square root of something, I can look for perfect squares. Like 300, I know would be the same thing as 3 times 100. So the square root of 3 times 100. And according to those radical rules, I can rewrite that as the square root of 3 times the square root of 100. So I write them separately. And the square root of 100, of course, is 10. So I'd have the root of 3 times 10, which I typically rewrite with the whole number out front. So 10 root 3. So that would be a simplification of that one. That's a nice one, eh? Here, similarly, I could do the same thing. Typically, when there's letters, I like to write them out. Same thing with a number like 12. I like to write that out as a product of factors. So 12 is 2 or 3 times 4. So I could write it as 3 times, well, and 4 is 2 times 2, times A, times there's 3 B's, times 2 C's. And then look for two exact things inside and bring one out. There's not 2 3's, so 3 is stuck inside there. Here there's 2 2's, I can bring 1 2 out. There's only one A, it's stuck inside. There's 3 B's, so there's 2 B's here, I can bring 1 B out, but I'm going to be stuck with a B inside. And I have 2 C's, I can bring 1 C out. So this would be the simplification of that one. Okay, if I'm multiplying radicals, as long as the indexes are the same, like I said at the start, I can multiply the stuff inside. However, rather than multiplying stuff, typically, again, I like to rewrite it out. So I'd write the cube root, and I'm going to write all of these as factors inside here. So I have a 3, and I have a couple x's, a y. 36 is 4 times 9, so that would be 2 times 2, and 3 times 3, and I have an x. Okay, it's a cube root, so I need 3 things to get 1 out. There's a 3, oh, there's 3 3's. I can bring 1 3 out. 1, 2, there's 3 x's. I can bring 1 x out. Any other things that I have 3 in there? I should have canceled some of these. So 3, 3, x, x, x. Looks like there's nothing else that I can bring out. So then I'm left with inside a 2 and a 2, so that's 4, and a y. So that would be the simplification of that product there. I can do the same thing with dividing. Notice here I've got the square root of 80 over square root of 5. I can rewrite that as the square root of 80 over 5. Notice that both of the indices here are 2, so this is allowed. If the indices were different, I couldn't have done that. 80 divided 5 is 16. The square root of 16 is equal to 4. Interesting that I came with something where I had a square root of 5, which is 2 point something or other. Square root of 80, which is, I don't know, 8 point something or other. But when I simplified that, I came out to just a whole number of plain old 4. Okay, save the best for last. This one, to simplify this one, it looks like a pretty decent kind of question. Because I've got different indices, and I also have multiple terms or multiple factors inside there. What I'm going to do is I'm going to take each one of those and write them separately. So I'm going to say the 4th root of x cubed, and I'm going to say the 4th root of y squared. And then on the bottom, I'll do likewise. So it'll be the cube root of x squared and the cube root of y. All right, I'm dying to cancel stuff, but they're inside different radicals, so I can't do that. But I could change these to fractional exponents. Let's do that with the top one. X to the 3/4, y to the 2/4, over x to the 2/3, and y to the 1/3. Now at this point, there's a couple of things that you could do. You could simply look at these and say, I'm dividing common bases, subtract their exponents. That might be the easiest thing for us to do. Let's try that. So if I'm dividing common bases, subtract their exponents, I'll need to get a common denominator there. So the denominator will be 12. So I'll leave this one as 12, put this one as 12. That means the top has to be 9. And if this one goes to 12, the top would have to be 8. So it'd be minus 8/12. And the y's, similarly, I go to 12, so the top would be 6/12, and this would be 4/12. So 6/12 minus 4/12 is 2/12. I guess I'll write it out. 6/12 minus 4/12. Okay, so in rewriting this, I'd have x to the 1/12 and y to the 2/12. Now, like we did before, each of these are 12s, and so I could, and again it's not factoring out, but it's using that same idea. Since they both have 12s, I can rewrite them so that both of them are raised to the 1/12, and it's always just 1/12 out there. But inside here, this x would be to the first, and this y would be to the second. So I could rewrite that as xy squared all to the 1/12. Or, just as the icing on the cake, I could rewrite it as a radical. It'd be the 12th root of xy squared. So those are a few examples of how you can multiply and divide and simplify radical expressions. Hopes it gives you help with your questions. Give your instructor a call if you have troubles.